Hey everyone, Patricia is here. So I just dove into the world of microchips. Seriously, the brains inside all of your devices and it completely blew my mind. Like, how does a phone do all the crazy stuff it does? It's not magic, it's complex science. And then I look into what's coming next and wow, our future is going to be wild. You know what? A microchip starts with this sand. Yep, silicon dioxide. Turns out it's not just for beaches. Engineers take this stuff to purify into insane degree like almost perfectly pure and melt into these giant crystal lugs called ingots. And then they slice those ingots into a super thin disc called wafers. Imagine a pepperoni slice but made of hyper-pure silicon and thinner than your fingernail. Now, silicon is a semiconductor, meaning it can be made to conduct or not conduct electricity. This is where the real genius comes in by adding tiny amounts of other elements like phosphorus or boron, a process called doping. They can create areas that are either p-type or n-type. These layers are the fundamental building blocks for something called a transistor. Think of a transistor as a microscopic on or off switch. Billions of these switches working together, that's how your computer calculates things. So, how do you build these tiny billions of switches in a clean room? And when I say clean, I mean obsessively clean. These places are something like 100 times cleaner than a surgical operating room. Even if a tiny speck of dust lands on a wafer, that part of the chip is ruined. Imagine wearing a full hazmat suit just to go to work every day. Crazy, right? The most mind-blowing step for me is the photolithography. It is basically like printing but with light. They coat the wafer with a light-sensitive chemical called photoresist. Then they shine incredibly precise UV light through a mask, which is like a stencil of the circuit design. The light changes the photoresist where it hits. After that, a developer washes away either the exposed or unexposed parts, leaving behind the circuit pattern. Then, they etch away the silicon in those unprotected areas. This happens over and over and over, layer by layer, until you have a complex 3D structure with a billion of transistors. They add the tiny copper wires, think incredibly like spider webs, to connect everything up. This whole process takes about 2 months for a single wafer. Once all the circuits are built, the wafer is cut into individual chips called dies. These dies are then packaged up, protecting them and allowing them to connect to circuit boards. And boom! You've got a CPU, the central processing unit, the brain of a computer. So why making chips is ridiculously hard? So here are the 3 main reasons. So, that's how we make the brains of today's tech. But what about tomorrow? What happens when these chips get even more powerful? I check out some of the top future technologies predicted for just 2025, like next year, and it's basically sci-fi coming true. First up, human augmentation. Think neural interfaces like Elon Musk, Neuralink, connecting our brains directly to computers. Sounds wild, right? Imagine controlling your devices with just your thoughts. Then there's the metaverse. We're talking about blending virtual and augmented reality into one seamless experience. Meeting friends, working, playing in a full immersive digital worlds. It's already happening with VR headsets. But it's going to get way more integrated into our lives. AI is going to be everywhere. We already have virtual assistants, but they'll be supercharged with generative AI, making them incredibly smart and conversational. Think Jarvis from Iron Man, but for real. And AI robotics, autonomous robots for everything from factories to personal assistants. Plus, better cybersecurity for AI and IoT will be crucial for everything as becomes connected. Two other huge ones, blockchain behind crypto. It's not just about Bitcoin anymore. Think secured supply chains, verified medical records, smart contracts that run themselves. It's all about trust and transparency without a central authority. And then, the ultimate game changer, quantum computing. This is not just about a faster, regular computer. It is a totally different way of processing information using quantum mechanics. It could solve problems that even today's supercomputers can touch, revolutionizing medicine, material science, and cryptography. Seriously, learning all this made me realize how incredible the world we live in. From a handful of sun to the chips that power our lives, and then to a future where augmenting ourselves and exploring quantum realms. It's just amazing. It makes me wonder what else is possible. So, what do you think? Which of these future technologies excites you the most? Thank you and see you next time!